I welcome everyone for this session on artificial intelligence on petroleum industry. And today we are going to discuss about reservoir modeling and a kind of algorithm which is going to be used. I mean, what is the significance of that algorithm used in reservoir modeling? So AI-driven reservoir modeling and characterization. So this is the topic that we are going to discuss today. So AI-driven reservoir model. First of all, we need to understand what is a model, reservoir model. Like when it comes to prediction, like we need to understand a kind of model. Like model will always help us to find out insights which were not available in the industry or current situation. Imagine today you have some data, you are having some analysis on that data. So right now you want to have some predictions. The reason for prediction is you need to have a structure for what could be the possibility of expected outcome for tomorrow's business. So for that we need a model. Like it could be uh, technical data or economic data or financial data or any kind of data that you might have. So you need to have that model. So when you are doing this process, AI earlier you have to do it with manual calculations, and one has to have good expertise knowledge to understand the kind of concept that you have so that you can predict the future. But today, because of artificial intelligence and its algorithms, which will help you, like it helps us to understand the complexity and variabilities of that data so that we can uh, overcome whatever constraints that we used to face when we were doing the same job earlier with conventional methods. But currently artificial intelligence is one of the powerful tool, so that it what it does is, like, you're going to give some inputs, like the way how we are doing earlier, the same thing only we are doing with AI. But the only thing is, here we are making a machine to learn. Earlier what happens is, we used to call some expert and he used to take the data. He will start analyzing with his own knowledge, with available either by literature or available resources and all that. When it comes to AI, the same thing it will do, but the scope is very huge. Like when you start giving inputs, by seeing that input itself, it will start learning on it. It happens with these are all unconventional methods when it comes to uh, an employee or an expert who is working on that. But when it comes to AI, you are giving an input, then it starts to analyze it and it will start learning through that input. And once you, when there is a constraint, when you ask, okay, from I need a solution from this, the or else I need a prediction model from this. So based on your input, whatever understanding it does by itself, it will provide you a kind of model. So this is the benefit of this AI in integration with reservoir modeling. So there are so many benefits are that it improves accuracy in predicting reservoir behavior and performance. So the data could be anything. So here when it comes to reservoir behavior, so that is the kind of data that you have given as an input. So based on that, it will try to provide you the insights. Faster and more efficient reservoir characterization and modeling process. Yes, this is something which is really beneficial for industry. Why? Because characterizing the reservoir could take a lot of time and it requires a lot of data integration experts. You have to wait until a expert team has to be hired. So these are all time-taking process. But when it comes to artificial intelligence, it doesn't require any expertise people. Rather, it will start understanding your data by its learning method, and then it will start applying to provide you a kind of model. So that model will help you to characterize reservoir and any other kind of performances that can be done. Enhanced decision making for reservoir management and optimization. Reservoir management is mainly for decision making, so that could take long period. You need lot of people to work on a particular project, provide the data and calculate the insights, and all that thing has to be done. But you can reduce all the time when you have AI with integrated reservoir model. So you can use in different areas like geological modeling and simulation modeling, data driven modeling. And when it comes to, while not just about the data driven modeling, rather data acquisition also you can use it, data validation, data cleaning. So data cleaning is also an important area where you may get data, but the data may not be having accurate values. Some kind of values will be having errors. That the range of a particular parameter, imagine if you have to consider, let us consider porosity. So porosity range will start from 10% to 30%. Imagine if you have data of 200 or 300, definitely it's an error. So to detecting such kind of errors, like, you need to closely monitor each data point by point and all that, which is very difficult for human to go through all that. And if the data is huge, the volume is very huge, millions of points are there, then it could become very difficult for detecting each and every error, every possible error. You might require an expert who can able to define that. But with the integration of AI, you can able to reduce all the errors in very less time will be consumed very less. So this is a huge advantage for petroleum industry. Why? Because we generate big amount of data, like huge data will be generated, so that can be worked through this AI. Then comes data transformation, feature selection, data integration, data resampling. So these are all parts of data analysis. So each detailedly, I have given the information to understand. So what is data transformation? Like, converting in one form to another form. Okay, so you may have tabular data, but you have to see that in graphical data. So rather than seeing a table, if you see a graph like scatter plot or bar graph or any kind of plot, that could become more, visually impactful rather than tabular form. So in that way, feature selections. So certain categories, separation of these categories, that and all comes under feature selection. Data integration. So well logging with reservoir, like kind of correlation. So you are correlating the information of well log with reservoir engineering. So we need to compare with this and get insights. So this also will be helpful when it comes to integrative AI. Data resampling. So when you have to repeat the process once again, AI is the best tool. Like, you already done certain samples, then hereafter you need to repeat it. Then there is no need for us to go in a traditional way to do all the things again and again. Rather, with the learning method of AI, it can provide you the best results. So one among this technique which we are going to apply in reservoir modeling is candidate elimination. So before entering into candidate elimination, this is an algorithm of AI, and we need to understand what actually is the significance of this method, candidate elimination. So the name itself says you are eliminating something. Your candidate, in the name here it was showing to be candidate. Here the candidate means parameters. So parameter elimination, you can simply name this as parameter elimination. So why this parameter elimination process is so significant, so that we can use it in our uh, petroleum engineering. See, when a case comes, imagine when a particular case comes, like, you have operations of different methods. Drilling operation is there, exploration, production operation, primary, secondary, tertiary, and a delineation process. All this process will be there. So you have generated huge amount of data. So with this combination of these processes, like, you have some range of values out there in exploration as well as drilling. and production, like that continuously you have different set of data. So these data you may have around 10 or 11 steps, like each step is giving you some outcome. Okay, when you take certain steps, it will give you a positive outcome, certain steps will give you negative. So like that you have certain number of steps. It could be around 10 steps you may take into consideration. Here you have 10 steps. Some steps are positive, some steps are negative. Okay, so each step is a variable. So like exploration, you have some range, and production, you have another range, and drilling, you have another range. So these are all samples. So right now what the question comes is, if you get a new sample with a random data of the range which was falling in this data, then can we decide whether it is going to be positive or negative? That is one question. Second question is, you may have 7 or 8 parameters, but these all parameters might not be the most important parameters. Certain parameters, it may not be that important. You have to understand some specific parameters play a significant role when it comes to production. Okay, so imagine if I have to give an example. Like you have the values of porosity, permeability, saturation, capillary pressure, and there is color of grain sizes in the reservoir. Okay, so you have certain parameters like this, and color of grain sizes in the reservoir is also a part of it. And finally the outcome is positive. So the colors were varying, at the same time these parameter values were also being varying. Ultimately at the end of the total table, you are seeing either positive values or negative values. So here what happens when it comes to candidate elimination, for it what it does is it will learn the data, and it will tell you maybe porosity might be more important, permeability might be more important. So I have certain parameters which are very important to decide whether the production is positive or not, but certain parameters are that I will eliminate. What is that parameter? Color of grain size. So it doesn't make any difference with production. So color could be any color, like color of grain size could be of any color, but that doesn't have any significance to this production decision. So if you have to go for a decision, you need to get a positive result. So this kind of parameters, it will try to eliminate. It could be like dimensionality reduction, elimination of parameters. Like this, there could be n number of cases that we can able to apply to understand whether we can keep these parameters for our consideration when it comes to decision making. Okay, this is the purpose of candidate elimination, and this comes under supervised learning. So this is also an important. You know the outcome, yes or no. So if you know the outcome, then the learning method we name it as supervised learning. If you don't know the outcome, like you are understanding the pattern of data and you are coming with some kind of information, a new information, that is unsupervised learning. Okay, so candidate elimination comes under supervised learning, and it has very good applications in petroleum industry. So let us start working on this. So before entering into candidate elimination, we need to talk about certain parameter values, and these parameter values will help you to understand why, because we are going to use these methods over there. So instance space in artificial intelligence, what do you mean by instance space? On this screen you are observing that there is a basket of fruits are there. So that means you have given this information to machine to learn it. So what does that mean is, it is observing that it is having possible attributes. How many possible attributes are there? It has n number of possible attributes. You can see all the number of fruits is considered to be n number of attributes. So instance space is nothing but that the basket is holding all the fruits. So the space inside a basket is considered to be instance space. So instance space means you have all attributes. These are not solutions. These are just attributes, possibilities of attributes. It is just attribute. You kept that value, all the possible attributes. Like you have given a, imagine if you are asking for a solution or anything, what are the all possible values that we have, it will show you. That is about your instance space. Okay, so let us come back to hypothesis space, which is very important. So when it comes to hypothesis space, you need to understand, you have given the kind of data to a machine to understand. So it starts, once you input the data, it will start understanding it. Okay, the fruits were given as data. So fruits, the size it will understand, the color it will understand, it will differentiate some fruits, like red represents apple, orange represents orange, and peaches represents another. Strawberry will be having red color, but it is having a separate shape. So this and all, it will start analyzing all these things, and it will try to provide you how many kinds of categories, like apples are there, oranges are there, it will categorize it. These are all like kind of data that you have given, it learned it, and it is telling you that these are the possible solutions. Like fruits, apples, how many are there, it will count and tell you. How many oranges are there, it will count it. How many fruits with the color of red, that also will tell you. These and all are learned by your machine, and it will be inputted in hypothesis space. So hypothesis space is set of rules and models. So it will create, like imagine if it is an apple, it should be red. If it is grape, it should be maroon. So like that, it will frame its rules, like by seeing these figures, the data point, it will create its own rule to understand this data. This is about hypothesis, and it will provide you, you have certain category of one fruit, second fruit, third fruit. If you ask some more categories, it will tell you what is that. Then comes, this is about hypothesis learning, and after that we have to go for concept learning. So there are two things here. Concept learning is there, semantic learning is there. So what do you mean by concept learning? So it is bit advanced to hypothesis space. Like hypothesis space, it will understand the data, and it will tell you, what kind of data that you have given. In concept learnings, it will learn, it will understand not just about the data. It is like distinguishment. It will not just about that. It will start to learn, yes, maybe this apple might have came from a tree. This is related to certain category of season. So certain fruits may be related to some other category of season. So it will understand deep knowledge about that. So why? Because it may integrate with these information with its available knowledge, and it will create a border, like it will understand, okay, these are actually learning possibilities of your hypothesis space. Hypothesis space is to categorize. If you say concept learning is to understand what is that fruit, what is the kind of fruit. Imagine if you ask something related to that fruit question also, it will answer in concept learning. Concept learning will help you to seriously to distinguish exactly the structure of the data. So earlier is just to categorize, but when it comes to concept learning, when you are asking something about the data, it will provide you the solution. So, and it will provide you the best solution. It's not just about all the solutions, it will be providing the best solution. So all the set of data that which was present in hypothesis space, out of all this data, it will find, imagine if you ask a question, I need to know which are apples and where they were located, or where they were this one, then it will try to find out exact locations of apples which are, imagine you have given another constraint, so which are touching with it, or which are from certain category or something like that. Concept learning will help you to identify that particular structures of apples which belong to that category. So it is even more advanced to hypothesis space. Just hypothesis space is to tell you the categories of data, but when it comes to concept learning, when you are asking related to the data itself, it will try to find out information from the data that you have given. It will try to acquire the knowledge, it will integrate with its keywords and all that, and finally it will provide you the data. You may have apples, but you want particular kind of apples which belong to so and so season. So in so category, so in so location, that will be that kind of outcomes can be uh, made up by concept learning. Then comes semantic learning. Semantic learning is a subfield of machine learning concerned with understanding the meaning of data, and it involves extracting and representing the relationship between concepts and their properties. So what is the analogy here is going beyond just identifying fruits. Semantic learning might involve understanding the apples are a type of fruit that they grow on trees and they can be sweet or tart. So these information you haven't given it. So semantic learning is also like concept learning. It will start like understanding with its own information. Apple is the one which you have given. So it will start to get more information from its own knowledge. I mean, it will be having that information. Then it will start to integrate with that and try to find a connection from your data towards general data. So when you are asking a sweet fruit, then it will try to pick apples and some kind of mangoes and something like that. But when you are asking for nutritious fruits which belongs to a particular vitamin or something, then it will try to pick related to that. So it will start integrating with general information. That is semantic. So right now, if you see in a simple sentence, instance spaces, what are the possible points that you have? Hypothesis spaces, it will try to formulate rules and models by the data that you have. Concept learning means it will acquire knowledge. The same thing with cementing learning under, it's also understanding the meaning and relationship between the concepts. So this is about your actual concept learning and hypothesis. So we are going to go with the algorithm with this data. So there is a very famous algorithm which is used to define the kind of outcome that you have. So you have some attributes over here, and the name of this algorithm is enjoy sport algorithm or example. So we have four instances, like as I said earlier, these are the possible four attributes that we have, and based on that we need to formulate, you have to make your machine to understand which parameters may play a significant role, and we will try to see that what are the parameters which are required to provide you the possible outcomes. So when you start working on this, first of all you need to know what is this example. You have four instances, and you have, like, you imagine enjoy sport. What is this type of example is a person whether he will enjoy sport if you follow all these attributes. So imagine in the same attributes you can fix our petroleum related data, and we can finally estimate whether the outcome is connected with the data, like production data, if the production is outcome or not, which are connected to it, like porosity, permeability, capillary pressure. So you can give all such kind of parameters over here, and you can finally check out whether it is suitable or not. Okay, so this example is general AI example. So this example can be contexted with any kind of data that you might have. It could be petroleum or any kind of energy data. Okay, let us try to understand this. So sky, air temperature, humidity, wind, water forecast. So these are like six attributes, and final outcome is adjustable, whether it is yes or no. So your outcome should be having decisions like either yes or no. So adjust mode either yes or no. So this is how the outcome will be. And let us see, if the sky we are having two attributes, sunny and rain. Air temperature you are having two attributes, warm and cold. Humidity normal, high. Wind strong and not strong, but there is no option for no strong. Like water, warm and cool. Forecast same and change. So based on these probable arrangements, you have the outcomes, whether it is yes or no. Yes, yes, no, no, like that we have. So right now what we have to do is we need to understand, how many possible instances it could create. When you are creating a hypothesis space, imagine sky, we have three kinds of possibilities: air temperature 2, humidity 2, wind 2, water 2, and forecast 2. So when you arrange all the possibilities, you will be getting 96. If you are putting, like when you are creating an hypothesis, you need to go with one more, you know, parameter, that is question mark and null. So question mark represent anything it will accept, null represent it will not accept anything. So when you add these two parameters to all the attributes, like 3 plus 2, 5, 2 plus 2, 4. So like that, if you add for all, then the possible instances will be 5130, which is, very huge volume, so that the machine might take more time to learn. Rather, if you reduce its dimensionality by reducing important parameter, I mean, what are the important parameters? We have to keep it, and remaining part we have to reduce it. Then the job becomes more easier and it will be more accurate. So let us see how it can be done like that. So first of all, we don't know which one has to be removed, whether it should be removed with, what are the things that we are supposed to see that. So firstly, we need to take, first of all, you need to take the first set of attributes like sunny, warm, normal, strong, warm, same, and yes. And we need to assign this to specific hypothesis and generic hypothesis. So I will tell you here, this is specific hypothesis, this is generic hypothesis. Specific means all belongs to none. So that is positive. If your outcome is positive, then you need to assign values to this. If your outcome is negative, means no. So decision is yes, you have to go for specific hypothesis, and when it is no, you have to go for generic hypothesis. How to assign this? Question mark means anything it may accept. Null means it will never accept anything. So let us start working on this. So first, out of the table, this is the first attribute, that is sunny, warm, normal, strong, warm, yes. So you can see the outcome is yes. So that means you are supposed to assign to yes, not to G. So this is specific hypothesis, this is generic hypothesis. So these values like sunny, warm, normal, strong, warm, same has to be assigned to that all the values earlier which was filled with null. So null values will be replaced with all these values since it is positive. So you can see the positive value, so it will be given to yes. If it is negative value, you have to go with G1. That is G, which is generic hypothesis. Okay, then after that, you have to compare this data with your second attribute. So let us see. So you can see when you keep second attribute, the top attribute and second attribute almost sunny, warm is same. Sunny, sunny, warm, warm, same. But when it comes to normal, there is a difference. So here, there is a criteria anomaly that you have detected. Again, strong, strong, warm, warm, same, same. So but the even though there is an anomaly, you have a positive outcome. So if that is the case, again you need to assign these values to specific. So right now, earlier it is S1 G1, so this is second iteration, so you have to go for S2 G2. So when it comes to S2 G2, so sun is same, that you can keep it as it is. Warm, warm, same, you can keep it as it is. But when it comes to normal and high, they were not same. So you need to use a question mark over there. So since these both are not same, so this parameter is in this hypothesis, it may represent it is not that significant. Then again, strong, strong, warm, warm, the same, and same, same, it is there. Okay, then generic, nothing to do. Why? Because the outcome is positive, so there is nothing to do with the generic hypothesis. So let us go for the third one. So when it comes to the third one, you can see, first of all, always we have to keep an eye on the last attribute, that is no. So that means you are supposed to go with generic, not specific. Why? Because you need to compare with the earlier values. That is what it was written here, earlier values. Then you need to assign the values at generic. Then what? This is your S2 G2. This is your the third one, S3 G3. So let us try to see what is happening with the new attribute with your old specific hypothesis. So sunny and rainy, which are not same. So again, if they are not same, you should not change anything over here. You have to change in generic hypothesis. How to change? So here you cannot use the format that you are using on S2, like specific hypothesis. The format for G2 will be, you have to see how many attributes are there. 1, 2, 3, 4, 5, 6. The first value is not same. Sunny, rain, it is not same. So you need to see on your attribute what is the value. If they were both are not same, then you have to take the opposite value of this. What is opposite value of rainy? That is sunny. Take the sunny on the first place, and the remaining all you keep it question mark, like 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So this is your first hypothesis instance, okay, for generic hypothesis. So you're going to use the first, value of it and take the opposite value to that. Like if it is rainy, sunny. If sunny, sunny same is there, then this will not exist. If it is rainy, we have to see the opposite values only, then that only has to be changed. So rainy is there, you have to change, go for sunny. Then let us come for warm and cold. Again, there is a change. Okay, so cold is there, which is an attribute. Opposite to cold is warm. So take it on the place of cold. So first one is rainy, that is question mark. Second one is in place of cold, opposite one, that is warm. And remaining all values will be question marks. Okay, this is how it will be. So what is the third one is question mark. So this is not significant, so you have to, no need to put that value. So you can there is no need to consider this value for generic values. Okay, generic hypothesis. So next to that, strong, strong, same. So no need to consider that. You need to see question marks and similarities. If both are similar, or if it is having question mark, you can ignore it. So strong, strong, same. Warm, warm, string, same. So no need to put any value, no changes, nothing to do. But again, the last value is change, and here it is same. So the change value, you have to take the opposite value, and you have to replace in its place. So before that, all should be question marks, question mark, question mark, question mark, question mark, question mark, and change will become same. Okay, so 1, 2, 3, 4, 5 question marks, and the last value have become same. Why? Because this is change. Opposite to this value is same. So this is how generic hypothesis values will be assigned. Okay. So up to now we have reached to the third attribute. So the specific attribute values were as it is when it is compared to S2. But when it comes to generic hypothesis, this is how we are supposed to assign. Then let us go for the last attribute. Then let us see. So you can see when it comes to fourth attribute, so you have to compare that with your specific attribute, which is your like S3, G3, this values. You have to compare with this, and the value is positive. Earlier one is negative, so you have gone for generic attribute. Right now, what you have to do is, since it is positive, you have to assign all the values to specific hypothesis. So let us see. First of all, first both are same, sunny, sunny. So you keep as it is as sunny. So this is the last value. So sunny to sunny, no problem. Warm to warm, again same. You can keep it as it is. Question mark, nothing to do, which is not safe. You keep the question mark. Again check. So strong, strong. Yes, strong, strong is there. Warm and cool. So since both are not same, when it comes to specific, you need to replace that value with question mark. And the last one is same change. Again, these both are not same. Same change. Again, you need to go for a question mark. So if that is the case, this is about the assignment for your specific hypothesis. But there is this, your job was done. When it comes to specific hypothesis, sunny, warm, strong, these are very important parameters, and other parameters may not be that important. So that is how the solution comes to. But when it comes to generic hypothesis, you can see the same values I kept here, but one value was highlighted with another color. I will tell you the reason. So sunny, all four question marks, warm, all four question marks, and when it comes to the last one, this belongs to the top, same, like which is change that have been opposite to that value, you have kept over here as same. But when it comes to specific hypothesis, that was not significant. When when the value was not significant in specific hypothesis, then related to that value in generic has to be removed. Why? Because wherever question marks are there, we are not considering that values in generic hypothesis, if you see from the starting itself. So right now the last value is having question mark. That means this one is not significant. Then corresponding to that, the value which was in generic hypothesis, that value has to be removed. If you remove that, then let us see what are the possible outcomes. Final attributes will be sunny, warm, and the middle one is not that significant, strong, and other two are question marks. And the last value for generic values will be sunny and warm. So how to understand these two is, forget about positive and negative over here. This will not have any uh, uh, connection with your final attribute. Right now what we can understand is, if the weather is sunny, warm, like air temperature is warm, and the third one wind if it is strong, then you may just try to cross check the values. Sunny, warm, strong. Sunny, warm, strong, yes. Sunny, warm, strong, again yes. And sunny, the third, I mean the last one, sunny, warm, strong, sunny, warm, strong, sunny, warm, strong. The third one is rainy, it is not warm, cold, and if it is strong, then the value is no. And sunny, warm, strong, the third one. So you can see all the three attributes are providing yes, yes, yes for this values. So that the other values like humidity and when it comes to water and forecast, so when it comes to specific, that is not given that significant. Let us come to generic, hypothesis. So sunny and warm alone. So sunny and warm alone. So sunny, warm, sunny, warm, sunny, warm. So these two are only the general hypothesis which will give you three yeses. But what is the difference between specific and general hypothesis? You can check out sunny, warm, strong. So here there is sunny, warm, strong, sunny, warm, strong, and strong is available for negative also. So that is which is no. So yes, since three outcomes are there which gives you positive value, that was given towards your specific. But when it comes to generate, it will take only positive values. Means the data which corresponds to only positive values, that alone will be taken for the outcome. When it comes to specific, it will take which are required at the same time which may contribute to positive outcomes. So this is how we can able to context what you say, complex problems, you can say case studies, you can integrate with a number of petroleum engineering related case studies. Like you can take hundreds of case studies and you can reduce dimensionality, reduce the important parameters, reduce, and finally you have to come to a conclusion that this probability could be an option for going for project, appraising a project. So if you are going for appraisal, you need to get decision. So that has to be positive. And your reservoir manager will analyze this data with candidate elimination method, and finally he will come to a conclusion. Probably these options could give us a positive result. So this is how we can able to come to a conclusion that this is a kind of algorithm that will be very uh, useful for reservoir engineering, reservoir managers, or petroleum engineers when they are taking decisions. Okay. So this is about candidate elimination, and let us try to see our next area in our next class. Thank you.